So in this tutorial, we're going to talk about Matlab functions and constants. So built-in functions and constants to be specific, and then how you can define your own functions later on. So by functions, what I mean is mathematical functions like sine, cosine, tangent, exponential, log, and square root. And so those are pretty much what you'd expect if you've ever coded in any other language before. So I can do sine of 0, gives me 0. I can do cos of 0, gives me 1. Tan of 0, of course, would be also 0. So let's look at these trigonometric functions for a little bit. So one thing is that because Matlab works on matrices, I can actually pass in more than just one number into sine. So suppose I use the matrix we had before, 1, 2, 3, 4. If I pass that to sine, what that does is it calculates the sine of every element of A and returns a matrix the same size as A. So I can do all of that separately, of course, just to show that it is indeed doing that individually for every element. And so all MATLAB functions generally work like that. Some other functions you might want to use is the exponential function. That's exp. There's the log, which is the opposite of the exponential. So if I do log of exp of 1, I should get back 1. I can do square root, sqrt. Okay, so those are some very simple elementary functions in MATLAB. There are also some built-in constants into MATLAB that you should know about. So for example, pi, that's just pi. So if you do something like have a variable called pi and you assign it to something else, now I cannot use the original variable pi anymore. So what I would do if I want pi back is I would go into my workspace and delete pi, right? And so now if I type pi again, it's now back to original pi. Generally, I would avoid overwriting built-in constants. So one weird thing about MATLAB is it doesn't have the variable e. So if you want the variable e, you actually have to do exp of 1, which is e to the power of 1, which is e. Another important constant is I. So if I do square root of minus 1, I get 0 plus 1 times I. I can also just type in I, and it would give me the same answer. So you can also do things like I times I, which should give you minus 1, or you can do I squared. So you do exponents using the hat symbol. So that also gives me minus 1. So there are also some important functions for initializing matrices that you should know about. So the first one is the I function. So you've seen I in the sense that if I have a matrix A, then A times I should equal A. And so I is the identity matrix, and it's a square matrix with 1s on the diagonal and 0s everywhere else. So suppose I want to create a 3 by 3 identity matrix. I could do something like this, which would be a little bit inefficient. right? Or I could do I3, which gives me the same thing. Another thing you might want to do is create a matrix of all zeros. So that's just the function zeros. So that gives me a 3 by 3 matrix of all zeros. If I want to specify different dimensions, so I don't want it to be a square, I can pass in multiple dimensions. There's also a function called ones, which does a similar thing. It creates a matrix of all ones. You pass in the size the same way. So the next thing I want to teach you guys to do is how to define your own functions. So generally, you want to, for every function you create, you want to put it into a new file. So I'm going to go new function. So it gives me some boilerplate code that I can use. And this is good because it'll help me explain the syntax of a function to you. So when we create a function, it starts with the word function. If your function returns things, you can specify the output arguments over here. If there are more than one output argument, you can specify it as an array. If there aren't any output arguments, you can get rid of this part completely. And if there's only one output argument, you can get rid of the brackets. So let's suppose I want to define the hyperbolic sine function, which Matlab probably already has, but we're going to do it anyway. So it's going to take one input argument called x and take an output called y. So Matlab has some useful syntax highlighting. It'll give us a warning, stating input argument x is unused since we haven't written any code yet, and then it's returning a value y, but we haven't set y to anything yet. So let's save what we have so far. You can do Command S or go to File Save. So we'll save it. So one thing to note is you have to save the function name has to be the same as the file name. And so, like I mentioned before, Matlab already has its own signage. So we don't want to overwrite Matlab signage. So we're going to call our signage something else. I'm going to call it my signage. I'm going to rename this file to my signage. Alright, so now I'm not getting that warning anymore. Okay, so we're going to define our own hyperbolic sine, which is defined as the exponential of the input minus the exponential of the negative of the input, and then taking 1/2 of that. So let's do that. So inside the function, I have to set y. Remember, because I was getting a warning that y was not set. It's p of x minus p of minus x. And then remember, I want to put a semicolon here so that I don't see the output of this expression. I'm going to get rid of this comment because this function is pretty trivial, but in general, if you have a complicated function, you should probably comment it so you remember what you were doing later on, or whoever else is reading your code will understand what you're doing. And so you can write comments using the %sign to comment code. So I'm going to save that. And I'm going to use this function. So my sin h, let's say 1, 0. Right, so we can see from this image that hyperbolic sine crosses 0 and then it increases as x increases. So that's what we should be seeing. Remember that MATLAB works with matrices though. So if I wanted to, I can say x goes from 0 to 10 and I want to calculate the hyperbolic sine for all of those values. I can just pass in x and I'll get back hyperbolic sine for all of those values. And so that's how you define your own function. Probably yours in the future will be more complicated than that, but hopefully that was a useful, simple example. So we're going to do one more function example here. It will illustrate some new concepts. So I'm going to, instead of clicking the new button and choosing function, I'm actually going to right click on the workspace and I can see an option to create a new file and I can create a new function that way. So I'm going to call this new function isEven. Okay. And so you can see MATLAB has already replaced, so before when we created a function from a new file, it called it untitled. But now that I've given it a name to start, MATLAB already knows to change the function name to that name. Okay, and I'm only going to have one output argument again so I can get rid of these brackets. And the input argument is going to be x. I'm going to add a comment, returns 1 if x is even. Okay, so if you've done programming before, you've probably heard of the modulo operator. Although I haven't mentioned it in this tutorial series yet, it does exist in MATLAB. So in MATLAB, because the %sign is used for comments, we do not use the %sign for modulo if you've done that in C or Java before. So instead, we use modulo by calling a function called mod. Do mod 2, 1, sorry, 2, 2, right, 3, 2. So basically it returns us the remainder. Okay, and so this should be very simple. We want to return 1 if x is even. So we know we want to mod 2. So y equals mod x 2. Okay, but we have a problem here because when you take the modulo of an even number with 2, you will get 0. But if you take an odd number modulo 2, you get 1. So that's kind of the opposite of what we want. But what we can do is we can use the tilde operator, which does a logical negation. So tilde 0 gives us 1 and tilde 1 gives us 0. So what we want is to put the tilde in front of the mod. Okay? And so now if I call isEven 1, 2, 3, 4, 5, we should get 1s in the spots where the input is even, which we do. So for 2 and 4 we get 1, for 1, 3, and 5 we get 0.